Hey everyone, welcome back to my YouTube channel. Today we're going to be learning about something called 2D lists and matrices in Python. Now before I start the video, please don't forget to subscribe to my YouTube channel because when we hit 100 subscribers, I'll do a special video. Now let's jump right in. So what is a 2D list or a matrix? Well, 2D lists are basically lists inside of lists. If you don't know what lists are, I have a video about that and I'll link it in the description. Now, we usually think of lists as collections of stuff like integers, strings, and other objects. But also remember that everything in Python is an object, and so lists can also be the objects inside of bigger lists. You can think of it as a large grid. In fact, it doesn't have to stop there. We can also make 3D and 4D lists. A matrix is a type of 2D list where the dimensions of the list are the same. This means that the number of things in each row is like the same as the number of rows themselves. So you can imagine it kind of like a chessboard with 8 rows and 8 columns. Now, let's make our own simple matrix. This one is going to be a 3 by 3. So this one, this is called my matrix, and when we run it, as you can see, it's not formatted that well, because again, it is just a list inside of a list. So if we want to visualize it, I kind of formatted it a little bit myself. The syntax is still correct here. I just kind of made it look a little more like a table, like a grid. But again, as you can see in the output, the first starting bracket and the ending bracket, they signify like the bigger list, and then each individual list has its own numbers as well. Now, let's talk about accessing a 2D array or a 2D list. So what we can do here is, let me just comment out this code and then uncomment this. So here, let's create another 3 by 3 matrix, and this time let's access its elements. Understanding how to find, add, and remove things is really important, especially when it comes to matrices, because just like lists, matrices are indexed starting from 0. This means that the first row is actually the 0th index, and the first element of that row is at the 0th index as well. Because computers start counting from 0, but humans start counting from 1, so there could be a little bit of confusion there. In this case, we're going to be indexing the first index of the matrix's first index. So if that's confusing, what that basically means is that we're trying to find the second element of the second row of the matrix. Another cool thing we can do is like modify or change the actual elements of a matrix. So we just index the element however we like, and then we change its value, because since lists are mutable, which means that they can be changed, so are 2D lists. Because all the properties that apply to a list also apply to matrices, because if you think about it, matrices are just lists that are nested lists, basically. Nested meaning that it's like a list inside of a list, and it could also be like a list inside of a list inside of a list, right? So we're going to explore a little bit of that later, but right now, we can also append, like remove and replace a lot of the stuff in the actual matrix, just like we can do in lists. Here we're setting this thing to 50. It's just arbitrary. You can set it to anything you like. So if we run this again, as you can see, we have 50 instead of 5 in the actual matrix, because we've modified that. And we can change this value to, you know, anything. We can change it to, let's say, just somebody's name as well, because when you run that, as you can see, we have like a mixture of integers and strings, because again, all the properties of a list also come in handy in the matrix, which means that since lists can be a collection of like diverse data types, a lot of different stuff, matrices can have that as well. So now let's talk about NumPy. So NumPy is basically a Python library which is kind of like a magic wand for our matrices. Using NumPy, we can work with matrices in such an easier way, especially if our lists are 3D, 4D, or any size of nested lists. NumPy makes our grid super powerful. It can handle big numbers, and it does most of the math for us, which I think is pretty neat. So now let's uncomment this. And so in the first example here, what we're going to be doing is we are going to be adding 2 matrices. And if you're like me, when I first learned this, you might think that adding two matrices is kind of like concatenating them, like when you take strings and you put them together. But actually this is super advanced because NumPy takes each individual element and matches that with the other matrices respective position and adds them together. So for example, 1 is added with 5, 2 is added with 6, 3 is added with 7, and 4 is added with 8. And so when we run this, as you can see, we have 6, 8, 10, 12, which is a sum. Oh, also I forgot to mention, if you want to import NumPy, it's really easy. You just have to say import NumPy as NP. I just want to use NP because it's kind of like a standard, and it's also much easier. And so again, yeah, NumPy is very, very powerful when it comes to this stuff. And if you're kind of confused by the array word, array just basically means list. Some other programming languages use the word array instead. And a NumPy array is very similar to a Python list, but there are a couple key differences. Like for example, NumPy arrays have they're better in terms of speed and memory, and also they can do a lot of more cool stuff. They have more attributes, more functions, and a lot of that other stuff that's really useful when it comes to data science and data analysis. But even in examples like these, they can be very useful. Now, let's see if we can multiply matrices, because multiplying sounds really crazy. I know, like how could you multiply two matrices? But it's actually possible, and it's very cool. So I'm gonna uncomment this, and what we're doing here is basically we're assigning this to a product variable where we're using the dot function, and the dot function basically just returns the product of two things. And it's really not limited. It could be an integer, a list, it could be a 2D list, 3D list, right? And so here, if we run this, alright, as you can see here, we have 19, 22, 43, and 15. Now you probably are very confused by what this means. So basically how multiplication works when it comes to matrices are that each row of the first matrix is multiplied by the columns of the second matrix. So let me make this a little better in terms so you can visualize it. So for example, 1 and 2 is going to be multiplied by 5 and 7, right? Because 5 and 7 is the first column. So how that's going to work is 1 is going to be multiplied by 5, and then 2 is going to be multiplied by 7. So 5 plus 14, because 14 is 7 times 2, is going to be 19. So that's where we get the 19 from. Now we're going to multiply 1 and 2 by the second column of the matrix B, which is 6 and 8. So 1 times 6 is 6. 2 times 8 is 16. So 6 plus 16 is 22. Now the next row is going to be multiplied by 5 and 7 again. So that's going to be 3 times 5, and then 4 times 7, and then finally it's going to be 3 and 4 with 6 and 8. So it's going to be 3 times 6 and 4 times 8. And so when you do all the math, and in fact you don't have to, but just for good practice, when you do the math, this is what you're going to end up with. But you don't have to do the math because NumPy does it for you. So I hope you liked this video. I hope you kind of understood how 2D lists and matrices really work, and I also hope you loved NumPy, because I use NumPy a lot and it's really useful. So if you learned something from this video, don't forget to drop a like, hit that subscribe button, and share this with all of your coder friends. I'll see you in the next video.